we saw in this lecture, we're going to discuss more examples involving the solutions or finding the solution of system of linear equations by inversion. So we have two methods. We have adjoints or inversion by adjoints and inversion by Gauss-Jordan. So we start off first with inversion by adjoints. So we are given here three equations with three unknowns. So again, what we have to do first is to transform our equations into a matrix form, following the format matrix E, which is the matrix of your coefficients, times X, or the matrix of the unknown, is equal to the matrix B, which is the matrix of our constants. So in this case, we'll have now matrix E that will be 1, 2, 3, have 3, 1, 2, 2, 3, 1. We have your unknown X, Y, and Z. Then we have your constants 4, 5, 6. So by adjoints, what we're going to consider first is this matrix A. Okay. So given now matrix A, so adjoints, we have to first consider or determine our cofactors. So we start off first with our first element. So that will now be A11. So it's positive. 1, 2, 3, 1. That will give us positive 1 minus 6. That is equal to negative 5. So next we have A1, 2. So E1, 1. So we'll have negative. We'll have now 2, 3, 3, 1. So that's equal now to 2 minus 9. And that's negative 7 times negative value, or that's equal now to positive 7. And then we'll have A13. So that's positive. So we'll have 2, 3, 1, 2. So we get 4 minus 3, and that's equal to positive 1. So next we move on to A21, and that's equal now to this is negative, so add, so it becomes negative, and we get 3, 2, 2, 1, or that's equal now to 3 minus 4, that's negative times negative 1, or that is positive 1. So next we have this element E22, it's positive. So we'll have 1, 3, 2, 1. So that is 1 minus 6, so that's negative. 5 times positive, so that's negative 5. And then lastly, we have 3, that's A, 2, 3. So that's negative. And we have 1, 3, 3, 2. So that's 2 minus 9. That's negative times negative 7, or that's positive 7. So next, we have cofactor of element 3, 1. So that is a positive cofactor. So that is 3, 1, 2, 3. So that's 9 minus 2. That's equal to 7. Get A3, 2. That's negative. So that is 1, 2, 2, 3. It's equal to 3 minus 4. That's negative times negative 1. That's 1. And lastly, we have A3, 3. That's positive. So you have 1, 2, 3, 1. Or that's 1 minus 6. That's equal to positive times negative 5. That's equal to 5. So from all the values of our cofactors, we can now write our matrix. So these are our computed values. So our cofactor matrix will now look like this one. So 5, 7, 1, 1, negative 5, 7, 7, 1, negative. And as our definition of adjoints is simply, so now take your adjoint, which is simply the transpose of your cofactor. So the adjoint now will be, this becomes your column, second column, and the third column, 1, 7, negative 5. So from our adjoints, we now know also from our previous discussion that your inverse is computed as the adjoint of the matrix divided by the determinant of your matrix. And for the determinant, A, that's equal to 1, 2, 3, 3, 1, 2, 2, 3, 1. If we're going to compute that, that will give you 18. So this is the determinant. So the determinant times your adjoint. So the inverse now of the coefficient matrix can be written as 5 over 18, 7 over 18, 1 over 18, 1 over 18, negative 5 over 18, 7 over 18, 7 over 18, 1 over 18, and negative 5 over 18. Okay, so with this inverse, we can now solve for our next step. So general form of our equation is matrix A the coefficients times the x, which is your unknowns, that's equal to the matrix B, which represents your constants. So our unknown can be computed as, so kung equation yan, ax equal to b. Solving for x, that can be written as b divided by a. Pero again, in our matrix, wala tayong division. So instead of b divided by a, we could write the matrix equation as b times the inverse of a. Okay? So we have solved this already. We know your constant, so we can solve for our unknown already. Okay? So for that, we now have your unknowns x, y, z is equal to our inverse negative 5 over 18, 7 over 18, it's 1 over 18, it's 1 over 18, negative 5 over 18, 7 over 18, 7 over 18, 1 over 18, and negative 5 over 18. It's multiplied to our constants 4, 5, 6. So for this, we'll have x. So ito, multiply natin dito. So that will be negative 5 times 4. That will be negative 5 times 4. That's negative 20 over 18 plus 1 times 6 over 18. So that's 6 over 18 plus 7 times 6. That's 42 over 18. And that will give us a value of, that's negative 20 plus 6 plus 42. Okay, so that's negative 5 times 4, it's negative 20 over 18. 1 times 5, that should be 5 over 18 plus 7 times 6, that's 42 over 18. Or that will give you, so negative 20 plus 5 plus 42 will give us 27 over 18. It's 27 over 18, or that's the same as 3 halves. So for y, so this row multiplied to our column, so that will be 7 times 4, that's 28 over 18. So plus negative 5 times 5, that's negative 25 over 18 plus 6 times 1, so 6 over 18, or that's now equal to 28 minus 25 plus 6, that's 9 over 18 or that is 1 half. And lastly, for z, this row multiplied to our constant. So we'll have 1 times 4 is 4 over 18 plus 7 times 5 is 35 over 18. 5 times 6, that's negative, so 30 minus 18, or that will give us 4 plus 35 minus 30 all over 18. That's 9 over 18, or that is 1 half, which is the same as our result from the Kramer's rule. Okay, so let's solve another example, number 2. So again, this is a system of 3 equations, 3 unknowns. So from our discussion, we transform now our equations in the form of a x equal to b. So for a, our coefficients, that will be 1, negative 2, 3, negative 3, 1, negative 2, 2, negative 3, 1. For our unknowns, that is now x, y, z, and that's equal to our constant, negative 4, 5, negative 6.